Okay, so starting with example 2, all right, it says find the measure of each angle in a regular hexagon, okay? So let's compare that to example 1 real quick, all right? So what these numbers in example 1 are just saying, what do all the angles have to add up to? We don't know, all right, what each individual angle within that pentagon has to equal. We just know that all 5 of them have to add up to 400 or 540 degrees, okay? So let's take a look at the fact that there's key things in here, okay? Hexagon, first of all right, means 6 sides, all right? So we know that, so 6 sides. But there's another key word in there, which is regular, all right? So what that regular right there means, okay, is that all the sides have to be the same, have to be congruent, and all the angles also have to be congruent, okay? So what we're going to do is we are going to find out what all of these angles have to add up to, but because all the angles have to be the same, we're going to divide it by 6, okay? So using n minus 2 times 180, we're going to do 6 minus 2 times 180, all right, which means we're going to get 4 times 180, all right, which gives us 720 degrees. So using that 720 degrees, that means that all 6 of those angles have to add up to 720. All 6 of the angles have to be the same. So we're going to divide that by 6, which means that each of those angles, all right, within that regular hexagon has to equal 120 degrees. If it didn't have this word regular in there, we couldn't do this question. All right, that word regular is saying that all 6 of those angles have to be the same. Okay? Okay, let's look at example 3 now. So it says find the measure of each interior angle, all right, of this quadrilateral. Okay, we don't know that it's regular. Okay, let's first, though, use n minus 2 times 180 to figure out what do all 4 of these angles have to add up to. Okay, so we're going to do 4 minus 2 times 180. 2 times 180 gives us 360 degrees. Okay, so that means that all 4 of those angles have to add up to equal 360 degrees. So let's do that. Let's add 3x plus x, which gives us 4x, all right, plus 90 plus 90 obviously equals 180. And now we're going to set that equal to 360. All right, so solving, you'd subtract out that 180, you'd divide out the 4, and you'd get x is equal to 45 degrees. Okay, let's look at this one. All right, so now it's a pentagon, okay? And if we go up above here, all right, we've already found out that the sum of the angles within a pentagon is 540 degrees, okay? So that means that if you would have, once again, did 5 minus 2 times 180, you're going to get 540 degrees, all right, for all 5 of those angles. So all 5 of these angles right here have to add up to 540. So if you combine like terms here, we're going to add the 2x, the 2x, the 3x, and the 3x, all right, and we're going to get 10x plus, and then if you combine the 14 plus 14 plus 142, you're going to get 170, and you're going to set that equal to 540. All right, solving that, you're going to get x is equal to 37. Okay. All right, so we're actually going to skip example 5, okay? And we're going to skip example 6, and we're actually going to come down to this theorem right here, the polygon exterior angles sum, okay? So here's what it says. The exterior angles of any convex polygon, all right, so once again, convex, all right, is 360 degrees, okay? So what that means is, let's just start by drawing like a triangle, okay? So we've talked about convex polygons before, okay? And I'm sorry, we've talked about exterior angles before, okay? So what I want us to do real quick, though, is I actually want to draw them out. So when you're drawing out these exterior angles, what we're doing is we're just extending out the sides, all right? So that it extends out past it, okay? But you want to make sure that it's almost rotational when we're drawing out all of them. So now I'm going to draw this one going out this way. All right, and then we're going to continue on, okay? So do you see how they almost, like, rotate around, okay? None of them are, like, kind of stopped by one another, okay? But what this exterior, the polygon exterior angle sum theorem is saying is that if you added, all right, this angle together, and this angle together, all right, that has to add up to equal 360 degrees. Now, I showed you using a triangle. This is true about any convex polygon. So this is also true about a pentagon, all right, that the sum of the exterior angles also has to be 360 for a pentagon. All right, for a decagon, for a dodecagon, all right, for a 21-sided figure. That's true for any single polygon that the exterior angles have to add up to 360 degrees, okay? So if we look at example 7, all right, we have a pentagon in here, okay? But if you notice, they're showing you all these exterior angles right here, okay? And using that polygon exterior angle sum theorem, we know that they have to add up to get 360 degrees. So if we combine like terms here, okay, you're going to add up all the x's, all right, combine your 10, -5, and -5, and what you'd ultimately get is 18x, and we're going to now set that equal to 360. Okay, because we're dealing with exterior angles. Dividing that out, all right, you're going to get x is equal to 20. Now, the question is asking you to find the measure of each exterior angle. All right, I'm not going to go through all of this, all right, but you just take that 20 and plug it back in. So like 5 times 20 gives us 100. All right, 2 times 20 gives us 40, and you can keep going on and on, okay? All right, I'm going to pause there, all right, and then come back and we'll finish this set of notes up.